Okay guys, so now we're going to talk about the impulse cases that you could have. Now for the first case, you have one object moving and the other is at rest, right? So one is moving at the speed of 4 meters per second, it's got a mass, and another one with a mass of 1.6 but initially at rest. After the collision, one moves at 1.5 and the other is moving at 5. Now, if you want to calculate the impulse on B by A, so we're calculating the impulse on who? On B. So therefore, we're going to take the mass of B and apply the impulse change or the impulse equation. So final velocity was 5 and initially was 0. So that gives you 8 newtons per second. You always have to give respect to the direction. Now the impulse of impulse on A by B. So we're calculating the impulse for A. So the mass of A, which is 3.5, initially it was moving with 4, and the final was 1.5. This gives you at the end is -8, which makes sense because the impulse on B was coming from this direction, and the impulses on A was coming from this direction. So this one is negative, this one is positive. Okay, usually the impulse is equal and opposite in direction, like we're talking about Newton's third law. Okay, now in this case, you've got two objects moving on with a head-on collision. You've got A with a speed of 3 and B with a speed of 2. They both have the same mass. So again, you apply the change for the change in momentum for the impulse. The mass was 2. And now the velocity of B was coming to the left, so it takes a negative sign. And sorry, this is for A. So as I was saying, so initially, the final velocity of A was -2, so it's moving to the left. And initially it was coming with a 3. The law has got a negative, so this gives you a -10 newton second, which is the impulse exerted by B. By symmetry, it's gonna be, the impulse on B is gonna be +10. So if you do the math, M it was 2. The final velocity of B was 3, and it was moving initially with -2, so negative and negative gives you a positive, so therefore the impulse is +10, okay? Now the last case was basically, you've got one object hits another and they stick together, right? So if they stick together, that means they have the same velocity. So if you want to calculate the impulse on B, this is B, so you want to get the mass of B, which was in this case 2, and the final velocity it was moving. So when they stick together, they both moved at 4 meters per second. So you have to calculate to put this as its final velocity, even though they moved together, but this its final velocity as well. So that's 4. Initially it was 0, so it's gonna take 8 newtons per second coming from this direction, so that's why it's positive. Now the impulse on A, which is exerted by B. So the mass of A was 4, right? And the final velocity was 4 to the right. It was coming with a 6. So that gives you a -8 newton second. And that's how you solve the cases of impulse. You always think of which object that you are exerting the impulse on and what happened to its velocity. You take its mass and then you take the change in its velocity with respect to the direction, and therefore you calculate it. Thank you.